हेलो स्टूडेंट्स। तो ये आपके लिए एक और वीडियो है जो कि है वर्क पे। ओके। और यहाँ पर आपको दो अलग अलग इमेजेस दिख रहे हैं। एक में एक पर्सन ने हैवी लोड कैरी करा हुआ है अपने ऊपर, और दूसरे इमेज में एक बच्चा अपनी एक वर्कशीट लेकर के कुछ काम कर रहा है। ओके, दैट मीन ही इज डूइंग सम वर्क that it can be homework. Okay, so we have to identify which one is doing work exactly by the physics. Okay, let's start. Okay, so what is work? Tell me one thing, students. In all of these images, which one is doing exactly work? Okay, because by physics, work is only said to be done when there is a displacement caused by the external applied force. Okay, so in the first image, one person is working on computer. कंप्यूटर पे कुछ काम कर रहा है, और इसमें सेकंड वाली इमेज में भी एक पर्सन कंप्यूटर पे कुछ काम कर रहा है. ओके, and in third image, one person is lifting some heavy load. Okay, and here some people are pushing a wall. Here one girl is pushing a wall, and here one person is pulling a donkey. So work, is there any kind of work are these person doing? No, these all of these will not consider as the work. Okay, they are doing physical activity, or physical work is being done by them. That means they are spending their energy, but their energy is not converting into any work done by the physics. Okay, because the work is can be done when there is the displacement on the object, in the object, or the force at which applied on that objects. And here one boy is applying force on a football. That means he is kicking that football. In this image we can say that this boy is doing some work on this football. Here and here man is performing some work. That means one person is carrying some heavy load on his head. Okay, you will say that he is doing some work. Okay, but by physics he is not doing any work. Okay, and how it is called as the work is not being done? So let's see. Okay, by the definition of work, work is said to be done when the force applied on a body makes the body moves. There is a displacement of the body. Means if there is any displacement, okay, displacement caused by the applied force, okay, applied force in the direction of applied force. Okay, then only the force will be, then only there will be work done. Here in this image one person is pushing the wall. क्या wall push होगी इससे? No, he cannot do that thing. That mean displacement is 0. Okay, displacement will be 0 here in the wall, so the work done will be 0, because by the formula of work done, that is the W is equals to the F into S. Okay, it is the formula of work done, F into S, यानी कि force into displacement caused by the force. And here in the second image one person is pushing the car. Car may be moved by pushing this man. That means there will be a work done, or work can be there. Okay, so now the measurement of work. How we can measure the work? The work is having the formula force into displacement. If there is a component with having some particular magnitude or numeric value, then it will be called as a work done. Okay, here the work done is having the formula F into S. Here there is one object is kept on the ground. okay, and external force F is applied on this object. This object is rest at point A at first, and after the application of force on this object moves to the point B at a particular distance from point A, that is considered as the small s. Okay, so if in this condition the displacement is 0, then the work done will be 0, because whenever we are multiply with 0 to anything, it will be eventually 0. Okay, here the exact expression of work, that is dW is equals to F into S cos theta. Okay, cos theta can be replaced by the sin theta. It depends on the value what we have to calculate. Okay, it is the right angle triangle. Okay, and suppose here we have to calculate the height of this right angle triangle. Suppose we have to calculate the BC height. BC, it will be the base. A to B, it will be considered as the base, and AC is called as the perpendicular. Okay, here it is the angle between the perpendicular and base, and we all know that the sine theta value, cos theta value, and tan theta value. Okay, sine theta is equals to perpendicular upon height, okay, and cos theta is equals to base upon hypotenuse. Hypotenuse means the perpendicular. Okay, tan theta is equals to perpendicular upon base. Okay, and here we have to calculate the height. Suppose we have to calculate the height, so which one will we consider here, cos theta or sin theta? So it will be the sin theta we have to use. I will show you how it is applied in this the formula of work done, that is the F into S cos theta. There are some numericals in your book. When we solve those numericals, I will show you the particular use of sin theta here in place of cos theta. Okay, next thing here, different cases of the work done. First case, when the work done is considered as the positive. Okay, in this condition the angle between the applied force and the displacement caused by the force having 0-degree angle. 0-degree means the displacement is caused in the same direction of applied force. In this condition, the angle between these things, it will be 0, and cos 0-degree value, we all know that it is 1. So we can say that if the formula I am using, W is equals to F into S and cos theta, it will be cos theta 0-degree, it will be 1, because cos 0-degree is equals to 1. So work will be considered as positively, because there will be some value of F into S. Alright, but if the angle is 90-degree, like this here, like this, the angle between the Earth's rotation in a circular pathway and the applied force by the sun to the earth, that is called as the gravitational force. We can understand this thing by one example. Here I am giving one object that is revolving or moving in a circular pathway, that is the A, B, C, D. Okay, D, A. Okay, there is the one object which is moving in a circular pathway like this. It is the direction of that object. It is the direction of motion. Here, suppose this object is at here. Again, it will having the direction of motion like this. Okay, but the gravitational force or the centrifugal force or centripetal force, it will be there. Centripetal force, that is the pulling force on that object acting towards its center. Okay, centrifugal force, oh sorry, centripetal force. That mean here the angle between the velocity, or we can say that the displacement and the force. Okay, displacement, it will be considered as the displacement and it will be the direction of force. So the angle between them is 90 degree, we can say. So the value of cos 90, it will be 0. So the work done will also be 0. Okay, here we can see that it is the displacement of object here. Okay, and it is the direction of centripetal force, that is the towards the center of that circular pathway. So here is also the angle between displacement and force is 90 degree. So the work done will be, the 0 because cos 90 is equals to 0. So whenever we are using the formula of work done, that is the F into S into cos 90 degree, it will be 0. Cos 90 degree, it will be 0. There is one more example of whenever we are moving a stone in a circular way. That means हमने क्या किया, स्टोन को एक धागे से बांध करके उस तरीके से जब हम घुमा रहे होते हैं, है ना. ठीक है, तो इस कंडीशन में क्या हो रहा है, सेंट्रीपिटल फोर्स लग रहा है जो कि सेंटर की तरफ लग रहा है, ये जो सर्कुलर पाथवे आपने क्रिएट करा है. ठीक है, और जो मोशन है स्टोन का वो जस्ट उसके परपेंडिकुलर डायरेक्शन में हो रहा है. That means in this condition also the work done will be considered as 0. All right.